Hi everyone, Miss Sanfini here. Today we're going to talk about evaluating piecewise functions. Before we can do that, we have to define what a piecewise function is. A piecewise function is a function made up of one or more functions. So if we look at example number 1, we have this picture here. We've got this function here and we have this function here. So when we say this piecewise graph below is made up of a blank function and another function, what do you think it is? What do you think this function looks like and this function looks like? Well, to me, this left one right here looks like part of an absolute value function because it's got that V shape. So we're going to fill that in here. The piecewise graph below is made up of an absolute value function, absolute value function, and what do we think this one looks like? This one's actually a cubic function, if you don't remember that from that unit that we did. Okay, so it's just important to recognize what type of functions you have. So using the graph, let's evaluate each of the following pieces here. So f of 0, what does that mean? Well, you should be saying f of 0 is a y value when x equals 0. So what we're going to do is we're going to go on the x-axis and we're going to find x is 0 and we're going to look up to the graph. What's that value right there? 1. So that is what f of 0 is. So again, f of 0 is a y value when x is 0. So x is 0 here, shoot up to 1. How about f of negative 4? Again, it's a y value, but this time when x is negative 4. So we're going to go 1, 2, 3, 4, and go up to the graph. Up 1, 2, 3, 4, 5. So f of negative 4 is 5. Now we're going to do f of 4. So we're going to go over 1, 2, 3, 4, and go to the graph, which is simply down 1. So we'll say negative 1. All right, now this is the hardest one. Find f of 2. So we're going to go over 2 and look at the graph. But how do I know whether to go up here or to go down here? And the question is answered by looking at the open or the closed circle. Here's the closed, here's the open. So we say that if it's a closed circle, it's equal to, and if it's an open circle, it's not equal. So here, there's not equal to. Up here is equal to. So you really want to look at all the closed dots. So we're going to go over to 2 on the x-axis, and then we're going to go up 1, 2, 3. Again, we don't go to the open circle because that's where it's not equal to. Okay, let's look at the second graph. So in the second graph, we want to analyze what this piecewise function is made up of. So what do you think this is, and what do you think this is? Well, I mean, this looks like an absolute value function again, and this looks like a line. So we'll say that the piecewise graph below is made up of an absolute value function and what's this guy? We said a line. How do we say that? We would say a linear function. So using the graph, we're going to evaluate the following things. So f of 0 means, again, a y value when x is 0. So when x is 0, y is 0. This case was easy. F of negative 4. So we're going to go to the x value of negative 4 and up to the point on the graph. Positive 4. F of 3. Well, let's see. We're going to go over 1, 2, 3, up 1, 2, 3. Okay? And f of 2 now. We're going to go over 2. Now again, do we go to this dot or this dot? We always want to go to the closed circle because at the open circle, it's not equal at that point. So we're going to go over 2, up 2. So this 2 is that point right there. All right. Why don't you try example number 3 all by yourself, and then I'll go over it. Okay. So for this example, this piecewise graph is actually made up of all lines. We've got a line here, a line here, and a line here. So that's what you wanted to put on this blank. The piecewise graph is made up of all linear functions. So let's take a look. Evaluate f of 0. So again, what's the y value when x is 0? So when x is 0, the y value here is negative 1. All right, let's look at f of negative 3. So when x is negative 3, do I look up here or down here? You want to be saying up because that's where the closed circle is. So negative 1, negative 2, negative 3, up 2. F of 4. tells us what's the y value when x is 4. You should have done 1, 2, 3, 4. Pick the closed circle, not the open. So -1 should be your answer. And this one was probably the hardest. Find all x when f of x equals -1. Remember, f of x is the same thing as saying y equals. So I'm basically asking you, find all x when y is equal to -1. So you want to look on the y-axis, find -1. Look at this. These are all the x values where y equals -1. So everywhere between when x is -3 and x is 1, 2, 3, 4, +4. So we would write from 3, -3 to 4. Now, do we do a bracket, open parenthesis? Since it's an open circle here, we're going to put a parenthesis. And since it's a bracket, a closed circle, we're going to put a bracket. Okay, moving on to the next page. Okay, now we're going to evaluate piecewise functions algebraically. Before we do that, there's just a quick typo, so let's change this to a 3. Okay, so now it says, evaluate the following algebraically and check using the graph. Show all work. So we've got a piecewise function made up of 3 different parts. We've got a quadratic, a line, and another line. So here's the first quadratic for when x is less than or equal to 1. Here's 1, all the numbers less than it make up the quadratic. The line y equals 3 is this horizontal line here from 1 to 2. So when x is 1, y is 2, we've got this line. And then we've got this line y equals x for when x is greater than 2. So here's 2, and we got that line there. So the first one says, find the y value when x is 0. So when x is 0, we need to figure out which of the 3 categories does that fall under. Well, x is between 1 and 2 would be here. X is greater than 2 would be here. So if x is less than 1, doesn't 0 be less than 1? So we have to use this. So algebraically, we would be plugging into the x squared function, and we'd plug in 0 squared, and we'd get 0. Let's check to see if it makes sense on the graph. F of 0 says, what is the y value when x is 0? X is 0, y is 0. Done. Okay, second example. What is f of -1? That's the y value when x is -1. Where does -1 fall? Is -1 an x value greater than 2? No. Is -1 an x value between 1 and 2? No. Is -1 an x value less than or equal to 1? Yes. So we're going to use this top one again. So we'll do x squared we're going to use, and we're going to plug in -1. -1 squared is 1. Let's check to see that it works. So f of -1 is a y value when x is -1. So when x is -1, y value 1. Checked out. Okay, now f of -2. So we're going to say, what is the y value when x is -2? So again, I think that falls under this category. -2 is an x value less than or equal to 1. So we're going to use the x squared. We're going to plug in -2, and we should get 4. Okay, let's check it out and see if it works. Okay, so we're going to look over on the x-axis where x is 2, -2, and we're going to go up 1, 2, 3, 4. There it is. It works out. Okay, f of 1. So which of these 2 categories would it fall under? X is less than or equal to 1, or x is greater than 1. You see how there's no line here? X is not equal to 1 there, and it shows it here on the graph. It's an open circle. It's equal to at this spot, so we have to use, again, the x squared. So -1 squared is 1, and again, we check it out. When x is -1, y is 1. Okay, f of 2. We're going to move and find which one where x is equal to 2. This one's greater than 2. This one's equal to 2, so we've got to use 3. I mean, there's nothing to plug in here. So look, the graph is easier to see. When x is 2, what is y? 3. Not this one, because that's where it's not equal to. So when x is 2, it's 1, 2, 3. And it's 3 every time. And then the last but not least, f of 3. 3 is a value x that's greater than 2, so we're just going to plug it into the x. So x is 3. Let's see if it works out. When x is 3, y is 1, 2, 3. Perfect. Okay, the last thing that I want to talk about today is matching piecewise functions. Well, here are three different piecewise functions and three different graphs. We're going to put an A, a B, and a C down here to see which one's which. Well, the first thing that I notice is that this is the only one that has an absolute value in it. This is a parabola, that's a line. These are all lines and maybe a curve. So this is the only absolute value, and this is the only absolute value here. So I'm going to cross off A and put it here. So now at a process of elimination, I've got two left for here. This one has a parabola, and I think this is a parabola too. But this one has 1, 2, 3 pieces, 1, 2, 3, and this one only has 1, 2. So 2 pieces, left over 3. Therefore, this has got to be B, and that's got to be C. All right, so come in tomorrow with questions. I know this might be a little tricky if you haven't seen it for the first time, and we'll definitely practice this again tomorrow.